Thank you very much. Good morning.
Yeah, good morning.
Online participants, thank you for the opportunity to come here to be able to talk about radiation around us. Also, thank you for the organizers of this Harmattan Medical Physics School and our moderator, Mr. Esogene Awariado. So today I'll be talking about radiation around us. So I'm going to be sharing my screen at the moment. Okay. I don't know if you can see my screen.
Not
Hello?
yet. Not yet. Not yet. Yeah.
Okay. Okay. Can we see it now?
Yes. Yes, we can. Yeah.
Okay. Thank you very much once again.
Yeah.
So radiation we hear about when we talk about radiation around us, most times people feel that, oh, radiation is just something that you find maybe in nuclear facilities or where in the hospitals or in factories where radiation or oil companies where radiation radioactive sources are used for peaceful purposes. But I want us to understand today that radiation is everywhere around us. Even where you are sitting at the moment, there is radiation. So radiation is naturally present in our environment, and this has been before the birth of the planet. We live in a radioactive world, that way, and radiation has always been all around us as part of our environment. Radiation is invisible to the eyes, it has no smell, cannot be heard. So it is nearly impossible to get a sense of it, but it exists around us, and is not limited to special places like nuclear facilities and medical institutions with therapy and radio diagnostic centers. It is everywhere in our surroundings. So I want to tell you this moment that where you are sitting in your office or at home, wherever you are, there's radiation around you. Okay, we are daily exposed to radiation from sources such as the ground, space, air, even the outer space that exists in nature. All this exists in nature without, we are exposed to radiation without realizing, just the way we breathe in air. Without, except maybe you are now ill, you're having issues with breathing problem, that's when you now know the importance that, oh, so I've been breathing all this way. That is the way radiation also is. But the only thing that makes us to come to realization is maybe someone is exposed to high radiation or one problem or the other. Okay, now, so we are exposed to radiation that exists in nature without realizing it, coupled with natural radiation contained in the human body and common foods. More so, exposure from areas of past nuclear bombings and testings like Hiroshima and Nagasaki, then also accidental power plants like the Fukushima, Three Man Islands, Chernobyl, and the rest. All this has contributed to the background radiation in the environment. And also, this has also led to exposure and radiation around us. Okay, now we have naturally occurring radioactive materials. These are called NAMPs. And these are materials that are found in the environment that contain radioactive elements of natural origin. That means these radioactive materials have been existing right from the foundation of the world. Many of them are buried under the ground. Some of them are on the surface of the earth, rocks, some from cosmic radiation, and even in the air we breathe in, there's radiation. This naturally occurring radioactive material contain uranium and thorium. And this case release radium and radon gas together with potassium. Naturally occurring radioactive materials are present in the earth crust, the floors, our walls, in our homes, schools, offices, and in the food we eat and drink. Also, there are radioactive gases in these radioactive gases, just like uranium and thorium. Those are parents. The uranium is the parent that decays down to the daughter products, thorium, to radium and radon. So radon is the gas, is a radioactive gas that we breathe in unconsciously. But most times, the people that really get more of this radon gas are those that have underground, like basements in their homes, because since this radioactive materials are found mostly under the ground, beneath the earth's surface. So those who have a lower depth, below sea level, they are more exposed to it. And radon gas most times have been found in areas like in the USA. Most of their houses have basements. So these radon gases are higher there. And also radon gases can be found in enclosed areas. You know that the walls, our walls, just as I said, our walls, our floors, everywhere, they are radioactive, but very low. Their background, this is background radiation. So I don't want to put any fear in us. It's not radiation that is harmful, just the background radiation. So okay, so this radon gas is also I don't know if you can help us.
Hello, please.
Okay, so these radon gases are found in enclosed area, places that have poor ventilation also, apart from basement. Now, also our bodies, our muscles, bones, and tissue contain naturally radioactive materials. How come? I'll talk about that. Hence, man is constantly living within a radiation field emanating from the earth and outside. Excuse me. Now look at this. If you look at this picture, this is the human body, taking up to 0.3 millisieverts, that's 8% of radiation. It's getting radiation from cosmic, that's from the outer space, from the atmosphere, radon from gases in basements or enclosed areas, minerals, rocks. Also, from medical procedures, they can also get radiation from artificial radioactivity. So all this, the human body is being exposed to this on a daily basis, apart from the medical one. Since the medical exposure is only when you go to, except those who are working in a radiation facility, and most times they receive very low doses because the areas are shielded. Okay, now the radiation dose that an individual can receive from the environment actually depends on the location, and this is influenced by the variation of soil and rock composition. Just I told you that the rocks are also there are some radioactive rocks, and we know that soil come from weathering of rocks. So when these radioactive rocks, weathering takes place in radioactive rocks, and it breaks down to the soil also contains these radioactive elements in them. Now, there are regions around the world where natural radiation is 2 to 10 times higher than other areas, like in Yangjiang in China, Kerala in India, and Ramsar in Iran. They have radiation levels that are far, far higher, even higher than public exposure. Because we know that normally under radiation protection, a radiation worker is supposed to take 20 millisieverts in a year, a minimum of 20, while the public is supposed to take 1 millisievert. But in locations like in Ramsar in Iran, their normal background radiation is 2.4. So now you see this standard that has been set by the international body for the public taking 1 millisievert cannot work in that kind of environment, because normally their background radiation is already high. And why is this so? This is because of the composition of the rocks, the soils in that environment. Probably they have more radioactive rocks, and the composition of the soil from the radioactive rocks, the radioactive materials, they are very high there. Now, the high levels of natural radiation in these regions are due to the fact that their soil have radioactive materials like the radium, thorium, and uranium. I've been talking about radioactive material naturally occurring. What's radioactivity? Radioactivity is the phenomenon of the spontaneous disintegration of unstable atomic nuclei to form more energetically stable atomic nuclei. Now, this comes from, like the uranium, we have uranium, because they are unstable, and for them to be able to attain stability, they have to break down. It is called decay. And that process of breaking down, that's what is called radioactivity. It breaks down. It does not just break down to form a two uranium. No, it breaks down to form thorium and gives off helium atom. That's alpha radiation. This is what radioactivity is all about. And also, now we've been talking about radiation around us, what is even this radiation? Radiation is the form of energy that comes from its source and travels through space. This type of energy has electric and magnetic field that are associated with it, together with wave-like properties. It can be categorized as ionizing and non-ionizing radiation. All what I've been talking about so far is about ionizing radiation, but we should understand that radiation is divided into ionizing and non-ionizing. We are going to look at that. Looking at this electromagnetic spectrum, we can see that it's divided into, I don't know if you can see the full screen, sorry, because I understand that our photos
can see the full screen.
Okay,
yeah,
thank you. Okay, now we can see that on the electromagnetic spectrum is divided into non-ionizing and ionizing radiation. The non-ionizing ones are the ones like the EMF sources, microwaves, visible light, radio frequency, and we see that they have longer wavelengths and lower frequencies, while those from the ionizing, the X-rays, cosmic radiation from the atmosphere, gamma radiation, they have shorter wavelengths, highly penetrating, high energy, high frequency. That is what I've been talking about all the while. So those naturally occurring radioactive materials, they fall under ionizing radiation. Why this other one of non-ionizing radiation, like our cell phone, our microwaves, our television, sunlight, satellites, and the rest, they are under non-ionizing radiation. So what is non-ionizing radiation? These are radiation that do not ionize atoms, but they have enough energy to move atoms in a molecule around or cause them to vibrate. This type of energy is not enough to remove electrons from an atom. Examples of, just as I said, they are the radio waves, visible light, microwaves, etc. Now, why ionizing radiation? Radiation that has so much energy to knock out electrons out of atoms. I believe we all know this. This process is known as ionization. And ionizing radiation, they can affect the atoms in living things, just as they affect atoms in living. That's the same way they affect our cells, the cells in our body. So they pose health risk by damaging our tissue and also DNA in genes. These are what brings about mutation. These are what brings about sometimes cancer. Leads to, that we have heard that radiation can also bring about cancer. It brings about radiation sickness, burns, and the rest. Ionizing radiation. Now, ionizing radiation comes from X-ray machines. Just, we know our X-ray machines. We have the one of diagnostic, that's the X-ray fluoroscopy, computed tomography, that's the CT. While we have the other ones, higher energy X-ray machines like the linear accelerator, cobalt 60 facility that produces gamma radiation. Also, the other one, like the brachytherapy machine that has a radioactive source that also produces gamma radiation. So these also cosmic particles from outer space and the radioactive elements that comes from that naturally occurring. All these are under ionizing radiation. These radioactive elements, they emit ionizing radiation as their atoms undergo radioactive decay. That's for the radioactive element, not the linear accelerator produces radiation electronically. It is electronically generated, while the other ones are just naturally. As they decay, they produce energy, and this energy is peacefully used in hospitals, in petroleum industries, in agriculture, and other areas, just like the word atom for peaceful use of radiation. Now, what is the radioactive decay? Is the emission of energy in the form of ionizing radiation. This ionizing radiation is emitted includes alpha particles, beta particles, gamma rays, and gamma rays, sometimes even neutrons and the rest. Radioactive decay occurs in unstable atoms called radionuclides. Just as I said, that uranium-238 is an unstable atom. Also, cobalt-60, though cobalt-60 does not exist naturally in nature, it's cobalt-59, but there are some other isotopes and radioactive elements that exist in nature, and they are continuously emitting radiation. So that continuous emission of radiation, as they are emitting the radiation, they are decaying. So now, looking at this chart, this is we can excuse me, we should understand that we have natural and artificial sources of radiation. Those excuse me, sorry, those naturally occurring radiation I talked about, they are under the natural sources of radiation, while the other ones of the artificial is the one that is man-made, that is produced by man, like the linear accelerator that is electronically generated, X-ray, fluoroscopy, computed tomography, that's the CT. Those are artificial sources of radiation. So now we can see from this pie chart here, looking at the various types of radiation, that radon is not artificial. Radon is natural, is the naturally occurring radioactive material, has the highest dose. We can see that radon from here, radon has 2 millisieverts. So someone who is living in a, let me say, in a story building and staying in the basement, and probably the environment has high background radiation, that person takes at least 2 millisieverts daily from radon, because this is the radiation around us. Yes, just as we are talking about. Now, also we see from the medical aspect, the medical aspect is 0.53 millisieverts. This is what happens from, this is what we get from some of these. Although for a patient that is undergoing a radiotherapy for cancer treatment, he or she is going to get far more than this. So we can see that there are natural and artificial sources of radiation. In the medical field where we are, where I am, we use both the natural sources of radiation and the artificial source of radiation to treat cancer. What I said it earlier, that the artificial source is that from the linear accelerator, while the natural is the cobalt-60 in a brachytherapy source. And also there are some teletherapy cobalt-60 machines that are also used to treat cancer. So those cobalt-60 there, those are the naturally occurring radiation, and they are natural sources of radiation. Now we see that we are daily, just as I said earlier, that we are daily exposed to radiation. Now, how does this exposure take place? We have both external and internal exposure to radiation. When we talk about external exposure to radiation, it's those that come from outside the body, just like you're in the environment now. Probably you're standing close to a radioactive source because you don't have a survey meter or radiation detecting device around you. You may not know that there is a radioactive source around you, and you're standing there. From there, you can be exposed to radiation. That is external. So those that come from outside the body and interact with us, they are called external source, exposure of radiation. And this occurs when all or parts of our body is exposed to a penetrating radiation field from an external source. This brings about interaction with our bodies. The source of radiation can be a piece of equipment, just like the X-ray machine, or it could be from a radioactive source in the like the brachytherapy machine. No, not brachytherapy, the teletherapy that uses cobalt-60 for treatment. Those are external exposure. Why the internal exposure arises from radioactive elements, which we take into our bodies through ingestion, inhalation, absorption, and injection. We're going to talk about that briefly. Now, when we talk about internal exposure through ingestion, this occurs through taking of food. We understand, since I said earlier that we have rocks, wedging of rocks brings about when rocks are being weathered, it brings about soil, and we put our crops in the soil. If these soils are radioactive, if, for example, you have soils that have some level of radiation in them, radioactive materials, naturally occurring radioactive materials in them, and you plant your crop there, definitely your crop is going to take up some of this radiation. That is why we have radiation now. But even in most of the foods we take in, we have radiation, but they are low levels. So this should not pose any form of fear to us. These are low levels of radiation that are taken into the body. Some of them are deposited in the bones, some in the tissues, but they are not harmful. Now, ingestion can occur through taking of food that contain radioactive elements like potassium. Potassium is found in most of our food. It's found in rice, in fruits, bananas, in fish. Most of the food we take in, we find potassium-40, and potassium-40 is radioactive. This has been absorbed from the soil through plant uptake. Also, when we drink water, sometimes, like for us that stay in Benin, we use in fact, I can say 90% or 95% of us in Benin, we use borehole water, and borehole water is gotten from where? Underground. Now, if in my environment, the naturally occurring radioactive sources, materials are very high, they are emitting high levels of radiation under the ground in the environment I am in, and I'm water from there. I use my borehole, use the water to cook, I use the water in water filter, and I drink it. It means that I'm also taking some levels of radiation, natural radiation, into my body. So you see that we can also get this through drinking water when you have, when the water is contaminated by radioactive elements, either on the surface or underground. Underground could be from maybe well, you have a well that has been dug, or you have borehole. Then the surface is maybe when there is contamination, maybe there's a radioactive accident, like the one that I think it's not that Fukushima in Japan, that the thing spilled into the sea. That one, that surface water there is already contaminated with radiation. So you see that if there's an animal that has drank that water, or a human being that has probably drank the water, the person will ingest radiation through that. Also, by inhalation, we breathe, just as I said, we breathe in air. As we breathe in air, if an environment is contaminated with radioactive dust, maybe from radiation accident or accident from nuclear facility and the rest, like this image here, you can see now, if, for example, if this is a nuclear power plant or a nuclear facility, and this is what is being given off into the atmosphere with these dust particles, anyone who is around there, because definitely these dust particles they will contain some levels of radiation in them. Anyone who is around there, because you cannot stay without breathing, you must breathe. That person breathes in these radioactive materials from the air in the form of gases, vapors, mist, or particulates. Then by absorption, how do we absorb this radiation? When I was doing my master's, there was an article I read of someone like a scavenger. A city was decommissioned. not city, sorry, a teletherapy using cobalt-60 was decommissioned, and they, they indiscriminately just dumped it without taking it back or doing proper decommissioning. Now, you know what scavengers do? They go, maybe they break down this metallic part, metals from the cobalt-60 teletherapy machine, not knowing that the source is still inside. So this person took it, and they have to take it they took it to their yard. From there, one of them saw it and handled it with his hand. that person that handled this radioactive source with his hand, not knowing what it is, because he does not have a detector in him to know that this is, just as I said earlier, that you cannot feel it, you cannot smell it, you can't see it, you can't hear it, does not have a sound, does not have a smell. There's no way you can look at and say this is a radioactive source. They said there is a meter to be able to measure the environment, to check if there's radiation. Now, this person handled it. By handling it, the person has because it is continuously emitting radiation. As that person handled the radioactive source, the person got radioactive radiation burns from high level of exposure to radiation from that radioactive source. Now, this is an example of someone who got exposed to high level of radiation. Look at you can see the palm. This one, when it was 4 days after the person handled it. This is 17 days after. I can't really see this one, is blocking it. Then look at what finally happened to the person's hand. Now, this person's hand has been damaged, but you should also understand that the internal structures has also absorbed this radiation. It's not just happening to just the surface, something is also happening within. This is radiation, internal radiation by absorption. Now, we can also have by injection and insertion. When someone is maybe if someone that is having cancer and he has come for brachytherapy treatment, radiation is inserted into the person's body. That's internal radiation. Also, maybe if someone that is going through nuclear medicine, taking in radiopharmaceuticals through injection. These are examples of internal radiation. And we can see from this image here. Look at how people get radiation from external source. Outer space, that outer space we can't do anything about, especially those of us that travel by air. Often we are exposed, because the higher you go, the higher the level of radiation. We are more exposed to radiation than those that do not travel by air. Now, body surface contamination, if there is an accident and there is dust, radioactive dust that has been, just like maybe terrorists just comes and puts it and detonates some maybe radioactive bombs and the rest. It brings about radioactive dust to the environment. Body surface contamination can take place through that. Suspended matters from a radiation generator, our buildings, the floor, all these are sources of external radiation. Why from the internal exposure? Just as I said, the inhalation, the food and drink consumption, when you inhale it, it gets to not you. When someone inhales the radioactive dust, it gets to the person's lungs, and from there it starts affecting, depending on the dose and the level of the energy. Now, also radiopharmaceuticals and the rest. So these are pathways through which radiation can get to some. Now, just as I said, the radiation cannot be seen, cannot be heard, can only be detected. How can we detect this radiation? This can only be done through radiation detecting devices. We should understand that the danger of ionizing radiation lies in the fact that the radiation is invisible and not detectable by human senses. People can neither see nor feel radiation, yet it deposits in the molecules of the body. And this can only be measured through the use of radiation, just as I said earlier. Some of these are radiation portal, personal radiation detectors, environmental survey monitoring devices, and radiation portal monitors. This is an example of radiation portal. This is mostly mounted in borders. This is why I said that I'm really, really bothered about our sorry, I'm going to divert a bit. I'm really bothered about our radiation level in our country, because I somehow sense that our borders are very, very porous. So we can see the security situation in the country. If some of these bandits or terrorists, they have access to some of these radioactive sources, they could use it to cause serious havoc. I don't know if we have this anywhere now. I don't know if we have this radiation portal monitor anywhere in our nation, in Nigeria, in any of the borders, because in advanced countries, this is what they have, so that any truck or any vehicle that is coming in, what we are seeing, you may just think that, oh, this is just a pillar whatsoever. These are mounted with radioactive detectors, such that any truck or any vehicle that passes through it, once the person is carrying any form of radiation in it, there is a monitor there that someone is in the office that senses the vehicle is going to be stopped immediately. There's going to be a search, and whatever the purpose of it, it will be thwarted. But here in our nation, I don't know if something like this is here. Okay, now we also let's leave that. Now we also have personal dosimeters. These are majorly used by radiation workers, either in radiotherapy or radiodiagnostic centers. So this does not protect against radiation. This only makes you to know the dose you have taken. You know, from the previous lecture, when the presenter was talking about, someone was asking about pregnancy and the rest. Even if the person is not pregnant, just a radiation worker at all, working in a radiation environment, he or she needs to always put on his dosimeter, so that at the end of the day we can check if the person has gotten more, or the person has gotten more than the standard dose for radiation worker, so that the person will know if he's doing well or not. Now, we also have this is for the environment, to be able to check the environment. These are these personal radiation detection devices, it can also be used if, for example, now you're working in an environment, you just mount it there on your dress. There's a hook there, and you're walking and there's radiation there. It will quickly tell you that, oh, there's radiation in this area. Then you'll be able to secure you protect yourself from this radiation. Now, radiation protection, this aims at protecting radiation workers and the public. We see that from here. I did not put patients because patients are not really protected from radiation, especially the ones that need radiation to be able to solve to be able to address one need or the other, maybe for diagnosis or for therapy. So radiation protection aims at protecting radiation workers and the public from uncontrolled sources of radiation that is above the background level. Now, there are 3 principles that needs to be adhered to when we're talking about radiation protection, especially during radiation emergencies, or where you find yourself where there is a radiation source. This is time, distance, and shielding. Now, the time that, for example, now, if let's say you're part of the public, you're not working in a radiation environment, and you just observe that there was an accident or there was a radiological emergency as a result of maybe accident from a nuclear power plant and the rest. The best thing to do, because you don't have a monitor with you don't have a dosimeter, even if you have a dosimeter, you should still go far away. You should spend less time near sources of radiation so that you don't receive radiation. Now, also, you should if you're in for example, for myself now, right now I'm in a brachytherapy suit. We have our brachytherapy machine inside with a radioactive source there that is continuously emitting. For example, if I go to carry out quality assurance on that brachytherapy source, I'll make sure that whatever I want to do, I've pre-planned before entering into the bunker, so that as soon as I enter the bunker, I'll quickly do everything. I will spend less time in the bunker so I don't take so much radiation. That's for that. Then for the distance, I talked about distance also. The farther you are from the radiation source, the less and the lower the radiation that you can take into your body. So you stay far away from the radiation source. Then also, if there is a shield, stay behind the shield. In every radiotherapy facility, whether it is radiotherapy or brachytherapy, there's always a maze. That maze, sorry, I think something like that. There is a wall there that is like a maze, somehow like a maze. That is concrete, is very, very thick, and it stops radiation from getting to whoever is there. So you can see that all these are the principles of radiation protection. And also, for those who are working in radiotherapy facility or radio diagnostic facility, as low as reasonably achievable, that's what should be done to be able to protect ourselves and the public from unnecessary exposure to radiation. Now, protecting yourself, for example, if there's a radiological emergency, you find yourself in a radiological emergency, maybe you just heard that, oh, they just detonated a nuclear explosive, not in Nigeria, somewhere. So what are you supposed to do? You find yourself there. What are you supposed to do? What you're supposed to do, number one, quickly get inside your house, not get inside your car. Go into a building, though the building has radiation because the walls are there, but far lower because that is background radiation. Get inside the building, stay inside the building, and stay tuned to know the next action to take. We cannot say that, oh, there was a radiological accident here, and the next thing you just start running helter-skelter. We should have this at the back of our mind that whenever there's a radiological emergency, we should stay in the building should not be the building where the radiological emergency took place. It should be a totally neutral place. So this is an image that shows it, that, for example, you are standing outside and maybe there was an accident from a nuclear facility. You are standing outside, you are not doing well, you are giving yourself unnecessary exposure. You are in a car, the car cannot protect you because it's just metal, radiation will pass through it. But you are in a building, no matter how small the building is like this, you stay indoors, you shut the windows, you shut the doors and close the windows, you are protected. So these are safest place to stay during a radiological emergency. Now, there are risks and benefits of radiation. Just as I said earlier, the risk, many times we have heard from researchers and the rest that we saw the bonds that I just showed earlier on. Someone that is exposed to high level of radiation can come down with radiation burns, can also have radiation sickness. Some die depending on the level of the radiation. If the radiation is very, very high, some of them die instantly, while some maybe after a few days. Because what happens? Why did they die? Because this radiation has been exposed to their bodies, it has affected the cells and organs and the rest. You understand? I said it affects DNA, it affects cells, so it can lead to death. Some of that time, depending on the dose, it can also lead to radiation sickness like vomiting, and those are nausea. Those are called radiation sickness. But more importantly, we have benefits that we get from the peaceful use of radiation. Radiation is being used medically to help treat cancer patients, also used medically to check internal structures for diagnosis of diseases. Also in the oil industry, it is used to be able to check the wells. In other industries, it's used to check cracks in metals, radiography, and the rest. Then also for agriculture, it is used there. In the military, it is used in almost every aspect. We use radiation, but radiation cannot be used by someone who is not qualified to use it. That is why they are very, very strict about the radioactive source. So you cannot just find it anywhere. Like in our NAMP platform, recently someone posted a picture of a radioactive source that was found, that was lost while being transported in Australia. We can see what happened. If drastic action was not taken, that radioactive source would have been there. It will not be, the radioactive source cannot be shouting, I'm here, I'm here, I'm here. And if maybe someone is even living in that environment, the person might just be getting the radiation unnecessarily. But because drastic action was taken, we can see that the radioactive source was quickly discovered and it was returned to where it's supposed to be. So we can see that we should understand that there is radiation around us. We cannot do without it. We cannot live. If you say you want to stay without radiation, that means you want to, even a dead body also is exposed to radiation, because when dead body is buried in the ground, the radioactive sources underneath is also exposing that dead body to radiation. So as long as you are you are alive, you are on earth, you are living, you are daily exposed to radiation, but background radiation, that is what? Low level radiation. Thank you very much. I hope I've been able to pass. Thank you for your time.